let's have a look at what might be the most over-engineered thing that has ever existed. The Apple iSight camera comes in this canister for some reason, and it has this nice lens cover, although there is a protective glass over it. There's an LED indicator. It has microphones internally. Has this swivel mount. It uses Firewire, but it's not using the DV protocol. It uses IIDC, which is something that machine vision cameras like this and this use in industrial settings. It's not compatible with DV. Comes in this canister, although you're probably never going to put it back in there, because what is the point? Well, when you buy the camera, it's not in this canister. It is supplied separately, and I'm not sure under what conditions you'd want to put it back in there, because you would normally have it set up on a stand like this for going on your desk or on top of a CRT monitor, or you would use a bracket like this to clamp it onto the top edge of your computer screen, or stand like this, which is double-sided tape there to allow it to be stuck to the back of your monitor so it can peek over and look at you. 6-pin Firewire cable was used because it needs the extra 2 pins for the power supply. A lot of DV cameras use the 4-pin Firewire connectors, and those have to be self-powered since these connectors only provide data, no power. Now, I wanted to show this working with the computer's output, and I got this whatever that thing is, mini DVI to HDMI adapter cable, but it doesn't want to work at all. Plug it in, the computer screen blanks for a short period of time and then comes back, but in the settings preferences there's no indication that another display is connected, and it blanks again briefly when you unplug it, so I can't get it to work. I've tried turning the computer off and on again, rebooting it, and it won't do anything. Anyway, let's try the camera. Plugs into the Firewire port on the side. And there it is. There's autofocus, which makes a little squeak noise. It's very slow. I also noticed you can use a Firewire hub to join more of these cameras up at the same time, and then you can pick them from this list. Hubs such as this. What I want to do is measure the voltage that is provided to the camera. Firewire can operate over a wide voltage. I think it's somewhere around 12 to 30 volts. And I've come up with a way we can measure it by using an inline Firewire repeater, which would allow you to use cables longer than 4 meters. So if we connect the camera through that, folded back to the internal camera, there you go. And now we can measure the voltage that's coming on the Firewire bus. And we'll look across the capacitor there. That must be the internal 3.3 volts. There we go. 11.2, so it's probably 12 volts with a voltage drop. You can hear the camera is trying to focus. If we were to stop this and unplug the camera, the voltage will probably be higher, 11.7. If the computer was connected to power at the same time, it would probably be even higher. There you go, 12.1. It might just use the battery voltage directly. I'm not sure what the standard battery voltage is on these computers. 11.7. So the computer provides 12 volts out of the Firewire port. Now we've seen it working, let's take one of these cameras apart, see what's inside it. There are 2 tiny little screws there. They seem to fit this JIS0 screwdriver. So we'll take those out first. I felt it loosening. that plastic part there, that white part is now loose. It does look like the whole assembly can slide out at some point. Quite a lot of room in there will be taken up by this swiveling part. This is going to get destroyed, unfortunately. Maybe it pulls out. Ah, there we go, look at that. That comes out. Then oh, there are grounding tabs, that's what was making the noise. Oh, the back part got stuck in there. Ah, that's because the little lens part for the LED, which is slightly protruded, has an inside bit which hooked onto that. So you can see two microphones there, and that tilt mechanism is probably taking up about half of the volume of the camera. And an extra ribbon cable connector not going anywhere. Peel off this cloth. Two microphones. I'm not sure if this is high quality microphones or not. I never actually tried to use them. If you plug one of these cameras into a Windows computer, it will usually blue screen it unless you've got the correct drivers installed, which usually come with machine vision type software. 3 pieces. Okay, so that's the camera coming out. We really need to take this frame apart first though. So there are screws there for the connector, various washers. I'm not sure if it will come out then, might have to push the rod out. I think that's retained in the housing somehow. We need to get this separated along here. I think there's clips. I'm not sure what direction they go in. When you buy these new, they come in a very also over-engineered box with several layers to it and all the bits laid out in a nice way. I unfortunately don't have the box for any of these ones anymore. Okay, we can see a large connector ribbon cable down there for probably just the image sensor as is, without any processing on this other than whatever that chip there does. And then there's another thin cable which goes down to the side, and I think that is what it uses to detect whether this front shutter thing is open or shut, because that will turn the camera on and off. The software knows whether it's open or shut. So let's take those out to release this latch. And that cable will slide out. So that's it for a camera, other than whatever processing happens on that board. So if they wanted to, they could have made it about this long with another bit of flex wrapped around with some parts on it to process the video signal. Didn't need to be that whole huge thing. I think you have to just slide that out or squeeze it out like that. And that has cable glued in there, the Firewire cable, probably to reduce strain on it as it's tilted so it's not going to break at the connector. Take out this board so we can inspect it. Looks like the microphone is just mounted on a flex. This board at the back unplugs. There must be extra parts that they couldn't fit on the main board. It looks like power supply components there, some inductors there, another one there under that sticker, a couple of little chips, multiple inductors. Now we can access these extra screws. So this probably isn't destroyed, we could put it back together. We didn't have to break anything. I thought we'd have to break something to get it out of this, because there wasn't any obvious way of opening it. Now it's going to be held in by these earth springs, washers, spring washers on the sides where we're retaining this. Oh, there's the microphone stuff. Ah, and there's a bit going up to the LED at the top there. How is that attached? I don't know, there's a really wide flex there with just 2 tracks on it going up to the LED. I'm not sure what's stopping that come out. I might end up destroying this. Oh, okay, it's a little clip that flies off. Ah, so it's just it's got a little bit of rigid on there where the LED is mounted, and there was a little clip, but that's now pinged away. So what holds this? I think it's just glued. Fujikawa. I think that must be the board manufacturer. Oh, lucky that cable unplugged instead of ripping. There's a TI chip there, DSP of some sort. Yeah, it's just a double-sided tab thing. It looks like it was stuck onto the label on top of the chip, which is now stuck on the other side of this. I wonder if there's anything under this shielding. Oh, that's soldered down. Yeah, there's something under there. Perhaps we should desolder all this shielding and take a look under there. Get the soldering iron warming up. Completely unrelated. Let's see what the power consumption is when we start the soldering iron. About 50 watts as it warms up. And then it starts bouncing around as it maintains the temperature, which we can see here. Yeah, so it goes from little bursts to solid pulses. So there's a little grounding strip coming off that board there. Might take a few goes as we lift up each part to clean the soldering tip. Fold it over the edge of the board. What's it soldered onto? Oh, it's just a really big lump of solder there. Right by some tiny little components. Yeah, soldered in these points. And that one there which was wrapped around. I wonder what that is. That was right under there. Ah, with a little thermal pad. So that thing must get hot. And the heat sinking it onto this, and that will also be acting as some shielding. Very interesting. We're done with the soldering iron. Now let's explore what we found. Some tape there. Tape over this capacitor. Wonder if that was in an area where it might touch. Yeah, I think it was because it's really close to that capacitor there. When that's assembled together like that, they could be touching. It's a little bit of a design oversight perhaps, placing the capacitors in such position. I wonder how the focusing motor works. Probably have two motors in there. And there's a fixed aperture, it might be fixed aperture. Just, yeah, f2.8, okay, so there'll be one motor in there, which is probably that, which has, what that, the motor will be a two-phase thing, so it'll have those 4 wires. And that's probably an optical sensor with common and an emitter and a receiver. Let's take this whole thing apart and find out for sure what's going on in here. So we'll unscrew the back here. That should expose the image sensor. Yeah, I've got 3 others, so it probably doesn't matter if we wreck one of them. There's the image sensor. 2003. There'll be an IR filter in there. Yeah, there it is. It looks blue when you look through it, but it reflects a red color, so that filters out the infrared light because that will make the colors go weird. Next layer, some black colored screws there which are hard to see. Not sure what else is involved here. Let's take off these silver colored screws. There's 3 of those around the edges. Okay, so that's the entire lens assembly here. So that leaves this front part, which is just that little shutter thing. Yeah, let's take that apart too. Take everything apart. Ah yes, so that will be an optical sensor, so that will be one too, to see whether it's open or not. And it's coming out the other side when these screws are undone. Feel the front coming out. Oh, look at that, it's all falling apart now. Yeah, so there's the shutter things. So you're supposed to do it up this way so that they sit there on little pegs, and then they're moved by these posts here. 3 little posts sticking out, which go through the slot in the shutter thing to move it. All 3 of them go at once. Yeah, they're dislodged. Need to use tweezers to put that back. And then that's a front glass piece. I think it's real glass. And just some smooth bits for those shutter tab thingies to go on. And then on the other side of that, there's little detent, so it makes a little click when it gets to each side, which must run in those dents there. And then there's a little photo interrupter thing, which goes on that little bit there, will pass between that gap and block some infrared light from reaching a receiver so that it knows whether it's open or shut. So this lens assembly, there was another screw from the other side, so there was 2, 1, 2, that one in the corner there, and now there's another one down the side there. That's why it wasn't coming apart. Now, oh no, here we go. Yep, so the one with the 4 wires, there's a little tiny motor there, and there's a photo sensor at the bottom, which will be so that it knows when it's in the home position, and then it can just pulse its little stepper motor to get it to another position knowing by the number of pulses. That will just lift this thing, this little part, up and down to adjust the focus. So coming off the motor, there's a cog there which you can see, and then this shaft here is a very fine spiral, really fine spiral, so fine it's hard to see, and that will be acting like a screw thread. So as that motor turns, it lifts this assembly up and down. You can see it moving a bit just on the play of this shaft now that it's got nothing holding it, normally retained by this piece. We're probably still in a position we can put it all back together, although it might be a bit dirty now. I'll look up some of these chips and see what we can find. One more thing before we continue that I forgot earlier. The way these brackets work is the cable connector is inside this housing thing. So to use any of the brackets, you put the cable through, or the connector through the hole, and then you get this two-piece housing, and you slide it together around the cable, and the connector goes down into that, and then that fits into there, and then the camera plugs into that, and there's little squeeze in clip bits that latch in so it stays locked in until you squeeze that in and pull it out. But I think it's supposed to, when you do that, you're squeezing the connector to hold it in place. In theory. Yeah, this connector might be quite an eager one. No. Anyway. Yeah, so it locks itself in quite tightly, and then the cable is unplugged separately. Yeah, it's quite a bit of fiddling around. There's lots of bits and pieces involved. Okay, we're going to look at the components that are on the board. First, this BGA under the little thermal heat spreader part. That is Fujitsu 13940 serial bus controller, 400 megabits. So it's got physical layer for going to the port, which is right there next to it. That's the data pairs there, and maybe that's the coupling for them. I think they'll go through those inductors there, little common mode choke thingies, and then pop up, go into the chip. So it's got all the bits and pieces, and then an interface, system interface with data and address lines. So that's the chip you need to join onto Firewire. And there's all the details of how that works. And so you can have up to 2 connectors on it. Okay, now other chips. TMS 320 DSP, so that will be doing image processing, and then that's got a flash memory for storing its firmware, and then I think that's RAM. Then we got these two here. This first one here, D2450R. That's a timing generator for progressive scan CCD image sensor. Timing generator. So that's got a crystal. So that'll be that thing there. That's 36.8 kilohertz perhaps. And then there'll be dividers, pulse generator, all these different types of pulses, vertical and horizontal. Generates all the different clocks and pulses needed for the image sensor. Look at that. That's for measuring to confirm its performance. All kinds of good stuff there. Application, block diagram, CCD. Takes that stuff. They've got some other things. Analog to digital converter, controller, signal processor. So instead of that CXA2006 that they show there, and analog to digital converter, we got this thing that I think does both of those jobs. That's a TI TLV990 10-bit 13 mega samples per second area CCD analog front end. Single chip CCD analog front end. So that must have the analog to digital converter. Yeah, 13 mega samples per second. There's what's going on inside. CCD data in, a whole bunch of things, and then data out. There's some DACs. It's probably for you to configure some reference voltages in the CCD sample and hooking it up. I suppose a bunch of the clocks go into this as well. Oh, that would be evident from the other one. Yeah, all that stuff would come into that chip from that timing generator. There's a little bit of stuff on the other side that those use. There's another crystal there, which would be for the DSP. Then we got on this backboard, or that was on the back, that's got a whole bunch of power supply stuff on it. These little tiny things, I didn't look up all of them, but the one I looked up was a P-FET. And then some of them might be dual FETs or transistors as well, because one of them has symmetric writing on it. But this little thing here, S29B, is this a LM3485 hysteretic P-FET buck controller. So that's one of those things that can go to 100% duty cycle, so it can go fully on. So you see there the input range is 4.5 to 35 volts, which is probably to allow it to operate over the full range of Firewire power. So it's probably connected wherever the power comes in from the Firewire port, probably goes straight up to this board and into that buck converter, and then gets turned into probably 5 volts or 3.3 volts, and then some other regulators after that to make other voltages. I think it's happening on internal layers. You can see there are tracks there that come off that subboard. They probably make their way over to these parts where the power will come in on the Firewire connector. So there's some doubled up ones at the end. Those are probably the power. And then you can see where you can see the data pairs, 2 there, ground, and then the other 2. And those 2 will be the power. Presumably, maybe those are grounds, or maybe those are both power and everything else is ground. Not sure exactly. Do we need to work it out? Not really. That stuff will be happening on here, and we'll be getting over to there and then going into the power supply circuit. It's there. That might be the power input. Yeah, under the connector. Yeah, so that's interesting. A little regulator, somewhat self-contained on this board. Suppose we could plug it back in and measure it. There's probably no need to do that. And then finally, the last one is this thing. So on this audio board with the 2 microphones, we've got this little chip here, Cirrus Logic low voltage stereo analog to digital converter. So that thing there, 24-bit, so that takes in 2 analog inputs, and then has got some sort of serial output as a I2S, I think there. It's got the left-right indicator, then the clock and the data. I think that's I2S. So it's possible you could hook this up as is and get some digital audio out of it. Yeah, they talk about that there, different formats. So there must be some configuration pins for setting that. There's also control stuff. Oh, it looks like it's got I2C or SPI perhaps. Yeah, 2-wire interface or I2C, or you can have it in SPI mode. So there's probably a bunch of registers that you need to write to configure how it's going to work. Presumably that comes from the host on here. The DSP will write and configure this thing. I/O and power control, interface control, clock ratios. So it might not be that easy to get working. You have to work out how the clocks and things work on this. I don't know if there's any crystal on this. Don't know if it needs it. Maybe it comes in. Is that how I2S works? Clock goes into this and clocks out the data. Perhaps that's what happens. Don't know, I have not used those interfaces before. Analog I/O control, mutes, volume control, gain, power down mode, master clock ratio. So digital interface format defaults to I2S, data valid on positive edge of S clock. Okay, so there's different amounts of bits, different resolutions you can have. Okay, so that's an interesting thing. Analog to digital converter for the microphones. So there we go. Apple iSight camera in pieces. Quite interesting pieces. I wonder if I should put that back together and try it out. Anyway, the cable that comes with it, that's what they write on it. No other type of part numbers or UL numbers. Presumably this is another one of those cables that frays and peels itself apart after a small amount of use. It's got a bit of strain relief, but still a very thin cable. Thought we were done? Not quite yet. I thought we might as well try these other cameras on the Apple computer, and they do work. Although this one here, it needs debayering externally, so the picture will only come up as kind of black and white, but it does work. So this is just a raw sensor output. That's, you got to process the the data coming out of it to turn it back into a color image. So let's try the other one. This one here has a built-in lens, and there are controls for it on the top. So the cameras come up in this list. So now we're using one of these. And yeah, this is a color one. Well, the other one was color. This one's got the debayering. There are buttons on the top which you can use to adjust the focus and the zoom. Quite tedious and fiddly. It has quite a close focus distance though. So it looks like Apple will support any IIDC type camera that you connect to the computer, which is interesting, but probably not very useful because these cameras are not very common and also not very cheap. Although I guess now people will be throwing them out because they're putting in new Ethernet based stuff these days in factories. Anyway, I think that's the end now for real.